racing, you depend on engine power and response to reach the winner's circle. And the new Renesis rotary engine delivers on both counts. This is the most powerful and best responding rotary engine I've ever driven on the track or on the freeway. And it has a number of key enhancements that allow it to run stronger and cleaner than ever before.
The advanced front midship layout of the RX-8 delivers aggressive packaging solutions for both power and people. This new Renesis rotary engine is normally aspirated, which helped engineers lower the overall height to just 13.3 inches. This is roughly the same height as the transmission, and by reducing the overall engine dimensions, Mazda engineers were also able to move the engine back 2.4 inches and down 1.6 inches. This improves weight distribution and lowers the center of gravity.
The new size and position of the Renesis rotary engine are just the beginning. The 13B multi-side port engine is more than just an improvement over previous rotary engines. It represents the next stage of rotary evolution, a new plateau for technology and performance.
To illustrate the many Renesis advancements, we'll start with the cooling system, and then work our way inside, through new intake ports, a new sequential dynamic air intake system, and a new metering oil pump. Along the way, we'll highlight the differences between the standard and high-power versions of this advanced Renesis power plant. So let's get started. The RX-8 is available with two engine choices, standard or high power. The standard power engine develops 207 horsepower at 7,200 RPM and 164 pound-feet of torque at 5,000 RPM. The high-powered engine is rated at 247 horsepower at 8,500 RPM and 159 pound-feet of torque at 5,500 RPM. The cooling system on the RX-8 is a conventional pressure system, and a degassing type coolant reserve tank has been integrated with an airtight sub-tank to improve the air-water separating function. A 12-pound pressure cap is attached to the coolant reserve tank to improve serviceability when adding engine coolant and bleeding air. The coolant level sensor is located on the side of the degas reserve tank. A warning light illuminates when the engine coolant level is below the specified amount. One of the main themes of the Renesis power plant is superior airflow management, and that includes other components in the engine bay. For example, the battery and PCM use a cool air ducting system. The PCM also has a switch that monitors its internal temperature. If the PCM temperature rises above specification, it turns on the cooling fans. When servicing the vehicle, ensure that the ducts and covers are correctly installed, and be careful not to damage or inhibit this system when jump-starting or changing the battery. Dual 2-speed cooling fans provide airflow to the radiator. The cooling fans are controlled by PCM-activated relays. If coolant temperature is above specification when the ignition is turned off, the cooling fans will remain on to reduce the coolant temperature. The RX-8 uses state-of-the-art drive-by-wire control. Not only does this system allow the computer to calculate optimal throttle opening at all times, it also allowed Mazda engineers to introduce an air conditioning cutoff control for better power and response during hard acceleration. When the throttle opening exceeds 65%, the PCM will momentarily turn off the AC for 5 seconds while the vehicle accelerates. The drive-by-wire control calculates the optimum target throttle valve opening angle at all ranges of engine speeds and controls the throttle valve actuator. The drive-by-wire control includes idle speed control, accelerator control, traction control, and cruise control. The PCM calculates a throttle valve opening angle matching the engine operation conditions and sends a duty signal to the throttle valve actuator, which then opens or closes the throttle valve. When the ignition switch is turned off, the main relay turns on so the ETC can perform a self-test to establish a fully closed throttle learning function. On models equipped with the high-power engine, air intake starts at the variable fresh air duct. At speeds of less than 5,500 RPM, the duct remains closed. Over 5,500 RPM, however, the duct opens, allowing more air to enter the intake system.
This is an important distinction between the standard and high-power engines, since most of the key differences between the two engines are contained in the air intake system.
Both engines feature a secondary shutter valve, or SSV. And a variable dynamic intake valve, or VDI. The standard engine uses a 4-port intake manifold, while the high-power engine uses a 6-port manifold. Below 3,500 RPM, airflow is directed through the ports in the intermediate housing. Above 3,500 RPM, the secondary shutter valve opens, and airflow is directed to a second set of intake ports in the front and rear rotor housings. At engine speeds below 5,800 RPM, the variable dynamic intake valve remains closed, which effectively creates independent long-length intake runners for each rotor. At speeds above 5,800 RPM on the standard engine and 7,300 RPM on the high-power engine, the VDI opens, shortening the intake length to incorporate dynamic air charging to fill the open intake tract with highly pressurized air bounced back from the closed intake tract. Models equipped with a high-power engine also feature auxiliary port valves, which feed more air into the additional intake ports, also located in the front and rear rotor housings. The auxiliary port valves remain closed until the engine reaches speeds of 6,250 RPM or higher. When the ignition is turned off, the main relay turns on, and the auxiliary port valves open and close to test their operation and keep the ports clean. Models equipped with the standard power engine have 4 injectors, while high-power engines use 6. The injectors are specially color-coded. Primary injectors, located in the intermediate housing on both engines, are orange. Secondary injectors, located in the intake manifold, are aqua on the standard power engine and yellow on the high-power engine. This advanced intake system is only part of the Renesas rotary engine story. Another key enhancement comes with the new side exhaust port configuration. The exhaust ports are now located in the intermediate and side housings, just like the intake ports. The main advantage of this configuration is that it eliminates overlap between the intake and exhaust ports, promoting better combustion and fuel economy. This 2-port configuration provides twice as much exhaust port area compared to the previous rotary engine. And relocating the exhaust ports to the rotary chamber side housings also provides a longer expansion cycle for improved power and efficiency. The Renesas rotary engine was designed for 5W20 weight non-synthetic oil, and to reduce oil consumption, a PCM-controlled metering oil pump with a position switch has been added. This position switch is set at the factory using special equipment and is not adjustable. If the switch is defective, loosened, or removed, the metering oil pump assembly must be replaced.